Testing. There we go. Okay, that was exciting. So I may have made a small boo-boo and I updated all the softwares like 20 minutes ago. That was a bad idea. You should not update all of your software right before getting ready to stream. But unfortunately, that's kind of what I wanted to talk about and play with tonight. So yeah, it's kind of a necessity. Kind of dumb. I probably updated a lot more stuff than I probably should have. So welcome back, everyone. This week was .NET Conf. So for people who are unfamiliar, I'm just going to jump right in. We're just going to jump right in. This. So if anybody wants the link for the conference. So as I record this is Wednesday, November 9th. The conference started on Tuesday, November 8th, Pacific time at like 8 a.m. Something like that. Give or take a little bit. The link there for .NET Conf. There's a bunch of stuff here. If you want to jump into like their win prizes from sponsors and find the clues, you only have until tomorrow. So if you're watching the recording of this on YouTube, sorry, you missed out. You can enter for a swag bag. There's some free digital backgrounds and whatnot out on GitHub if you want those. But more importantly, this link down here on YouTube. I wanted to call this one out specifically. So I'm going to go over a bunch of the... Oh, stop playing. I'm going to go over a bunch of the stuff that got announced. But if you click on the .NET one, worth subscribing if you haven't. But they have this .NET Conf 2022. Make that a little bigger. Playlist of all the stuff. And so you've got kind of the whole day 1, day 2 options if you want. But if you're looking for just individual sessions of stuff that is interesting to you, they do have a bunch of the individual sessions set up here. Where you can dive into just getting those ones there as well. So worth checking out this .NET Conf 2022 playlist if you want to see some of the cool stuff there. 2 announcements that got me really excited that I think are totally awesome. We're going to start with dev tunnels. So drop a link to this if people are interested. So for anybody who's worked with tools like maybe ngrok, this is built-in support for this. So this is affectionately usually referred to as a reverse proxy. But the idea is sometimes you want to run like a web service, an ASP.NET Core app locally on your system, but you need something else to be able to hit that local system via a publicly accessible URL. Hence the reverse proxy idea, right? There's a proxy in the internet that has some sort of DNSable name that something else can hit, but you want that to get routed down onto your local running instance because you're debugging, building, whatever. Oftentimes this gets used when you're building out like webhooks. So for example, you're building an endpoint that's designed to be invoked by a webhook and you want to validate that integration works, but you don't want to publish it, right? You want to debug locally to like, see the payload coming in or whatever, right? So dev tunnels is exactly that. And the demo that they did, it was actually developer A was working on an app, fired up the dev tunnels locally, sent the link via Teams or insert favorite chat application here over to another developer on her team. That other developer was able to load up the running app that was local on her teammate's system. And then I think they had Swagger open and they just invoked some endpoints there. So it's actually a pretty cool thing to be able to go through and set up. And the fact that this is not that complicated to get up and going, right? So you end up running the app locally, but then going through, what is it? The VS tunnel, something or another, randomly generated thing underneath visualstudio.com, it automatically routes it in, which is just absolutely awesome, right? Like this is an awesome feature. So worth noting, all the stuff I'm going to be showing off tonight, if you aren't at least on Visual Studio 2022 17.4, you probably aren't going to get access. This request access to the feature too, like even though this is on the docs page, as the form indicates, this is no longer a sign up thing. It's out. So At some point, this bullet point will probably disappear off the list. And I can't recall if we actually need to have, if this is a preview feature. We can go look real quick. Let's look. Tools, options. So also worth noting, a lot of the stuff I'm going to show tonight is new to me too. So there's going to be a little bit of experimentation and learning. Yeah, so enable dev tunnels for web applications. I've already got it enabled. It is still under preview features on Visual Studio. So that step is still required. But yeah, so this one got me quite excited because I've done a lot of work building out ASP.NET Core applications that had to do webhooky related stuff, and being able to have a built-in reverse proxy without needing to rely on third-party tools like ngrok was pretty slick. Okay, next one that I thought was really cool. So if you've ever tried to build out any sort of auth inside of ASP.NET Core, it can be a bit of a pain for testing out JOT tokens or JSON Web Tokens, but most people call them JWTs or JOTs. There is a .NET Global tool that you can grab that lets you build up and create your own dev JOT tokens so that you can actually test passing different things in. So, okay, I want a user that has, let's see, I think they've got a sample down here. Schemas bearer, show all. Yeah, but you can build up a JOT token and specify what scopes you want it to have. So rather than having to go through and muck with whatever system is actually doing your identity bits, you can use this to be able to effectively test your identity work. So you'll note in this example here, a lot of the .NET Conf was showing off minimal APIs, which are cool. They got some improvements. That's great. Yeah. So just be aware when you're looking at this is minimal API stuff. But if you go through and set this up, this allows you to specify different scopes or claims coming through on your tokens so that you can validate them here. Which, again, one of those things that used to be kind of a pain in the neck to test that is now just a lot easier. Like, this is one of the awesome things about being a .NET developer. My heavily biased opinion is our tooling is awesome. Like, .NET tooling and ecosystem is just straight awesome. Some of the stuff that we can do with debugging is absolutely amazing, right? Like, I can attach to a running thing out in Azure, set a breakpoint without bringing down production and step through things. Like, it is absolutely amazing. Okay, cool. Sorry, my Visual Studio installer just finished updating all the things. Okay, so those were just a couple things from NET Conf that I got really excited about when I saw. I was like, this is pretty slick. There is a lot of good information in those sessions for .NET Conf, and I'll be honest, I haven't gotten through all of the day 2 stuff, which was today. So I briefly got through some of the C# bits. A lot of it I was somewhat familiar with already because I've been watching the previews, and C#, for those people who may be new to it, is open source now. So it's kind of hard for them to surprise the community with new features in C# because most of the time, like, the language design meetings are held on YouTube where anyone can watch. Like, it's kind of hard to surprise people. The repos are open source. Like, yeah, you can still sneak some stuff in if people aren't paying attention, but there's kind of a lot of people watching. So I think they've given up on doing the surprise reveal. It's like, yeah, this is what's coming. The only surprise is which features make it into the final release, which ones don't. Because I think I heard somebody on the C# team once comment that the team has deep-seated commitment issues. And so they will never guarantee that a feature is going to make it into a release until it actually ships. So once it ships, then you can rely on it. But up until it ships, yeah, there's no promises. Okay, so I did want to call out. So there are a couple pages I'm going to drop links to here of what's new in. Let me just fix the links up so that, because mine are set to English. So real quick, a brief discussion on the subtle but important difference between .NET 7 and C# 11. So this is one of the things that oftentimes I see people get all confused about. So this stuff just released yesterday, and me being the crazy person I am, it's like, I like living on the bleeding edge. Let's update all the things, right? I will probably start updating a lot of my open source projects to latest and greatest stuff. But the one thing that's important to remember is in order to leverage any of these features, the people working on it have to have the latest tool chain. So that typically boils down to installing the latest .NET SDK and or latest Visual Studio update. Right? So if you're doing like VS Code development, you need to download the latest SDK to make sure you're good there. If you're in Visual Studio, generally, if you're just doing latest and greatest, updating Visual Studio will get you the latest SDK to start playing with. And what that ends up meaning is when a compile happens, when you run .NET Build or F5 in Visual Studio, MS Build kicks off, looks at your project file, builds up a set of files, and those files get passed to a program called csc.exe, which is the C# compiler. Or codename Roslyn, which I'm pretty sure the repo name on GitHub is still Roslyn. Regardless, files get built, passed to the compiler. Compiler reads in the files, does the needful, generates your assembly, out we go, right? Everyone's happy. To leverage language features, you just need the latest compiler. So I'll say that again. To leverage the latest language features, so C#11, you need the latest compiler. Now, where that gets a little bit murky is sometimes language features also require the latest version of .NET. And so depending on the type of project you're building, it's usually fairly easy to update your language version, but it may be harder to update your framework version. So for example, I do a lot of WPF work. If I go and update my framework on a WPF app to NET 7, what that means is now every computer I want to deploy my WPF app onto needs to have NET 7 available. And I'm kind of phrasing it that way intentionally because NET 7 available, like I could bundle it in, package, single exe, all that jazz. There's options. But in order for my app to run, I'm going to need NET 7, right? Whereas to use latest language features, the developer, just needs to have the latest tooling. So quite often, especially if you're working in a big company, revving the framework version is usually a little bit of a bigger conversation, right? It's how much do you control the people installing, how your deployments work, right? If you're pushing out like an ASP.NET Core application onto a server somewhere, you need to make sure that whatever's running it has the appropriate runtime installed. So if you're inside of like a Docker container, bumping that version up just to make sure that you are now inside of a container that has the NET 7 runtime. Because even though the compiler may generate that assembly, if you're leveraging newer framework features, you need that with your app in order for it to work. So revving to NET 7, so revving both is always good. But it's important to note that you can rev these things independently. And oftentimes people forget about that. They're like, oh, C#11 came out. We can't update right away. You know, that's a big conversation. It's like, why? Did all your developers update their Visual Studio? Yeah? Great. Let's just update our Lang version to C#11. Now, not all the features are available because, like, for example, C#10, they added default interface implementations. That required both language changes and runtime changes. So to leverage that, like you may be having the latest SDK, but for it to work, you still need the latest runtime there. Okay, so we're gonna start running through some of these because some of these I kind of want to dive into a little more deeply and play with a little bit more. So this thing here, these are currently preview features. You must set Lang version to preview. As of Tuesday, this is a lie. So as of November 8th, this is no longer true. So how you can tell if it's true or not is you grab yourself a terminal and you go .NET -- list SDKs. Right? So you can see, oh, I've got a couple old ones I should probably clear out. Like I don't need these ones here. But the important thing is I've got 7.0.100. And if you are interested, the way the .NET does the versioning is kind of a little bit weird. There's actually 4 parts to the version. Part 1, part 2. This first digit here is part 3, and then this is part 4, which is why you see versioning that ends up looking like this. So the .NET SDK does not follow semantic versioning. So you just need to be mildly aware of that. And typically that doesn't matter. Usually that isn't a big thing, right? Because the .NET tooling, them revving this from 301 to 305, you're not referencing it as an assembly, right? You're referencing the framework, which is different. So this going from 301 to 305, yeah, you can kind of treat it like semantic versioning. But you do not need to set your lang version to preview because this SDK is no longer preview. If you've got a previous NET 7 SDK that has the hyphen preview on there, you probably want to get rid of it. So I got bit because I run both Visual Studio and Visual Studio Preview. And for some reason, after updating VS 2022 Preview to the latest release that dropped yesterday, I had a stray 7.0.100 something or another preview SDK floating around that was causing me all kinds of grief. So if you update and you have problems, just go check your list of SDKs, get rid of anything you don't need. And in case you're unaware, you uninstall the SDKs by doing just add remove programs. Hey, thanks. It is good to be online again. One other thing I will comment on. I'm starting to put together a plan to do small, like 10-minute or less YouTube videos on various C# and WPF topics. So if you aren't following me on YouTube, shameless plug, link will come by in the bottom. You'll figure out my URL scheme. But I figured I would start doing those. That way it's smaller, easier, digestible chunks. And more importantly, I can answer a single question in 10 minutes and then just hyperlink people to it. It's really fun when people ask a question and I just send them YouTube links. I enjoy it. Okay, so we got here. One other comment I will make. So here, I just went file, new project, console app. I'd love to see something about NET 7. Well, you are in luck tonight. That's where we're going. We are going to play with all the new features. So I just did brand new console application. If you're familiar with the default project template for NET 6, not shocking. It looks pretty much the same. The 6 turned into a 7. Who would have thunk? And you can see top level statements, standard default project template. The one thing that I will also mention as well is people, let's see, there is a blog that came out recently. Let's see, NET 7 standard support. I'm trying to remember was this what they updated? So Microsoft updated their support policy naming, and this is by name only because people got weirded out by. Yeah, so this is where it is. This is the guy. This is the guy. I knew I saw it. People were getting a little freaked out about how .NET does their versioning. So they renamed it just so that people were clear that the standard term support, STS, just means that they're going to happen. They're only going to support it for a shorter period of time, right? Versus LTS. And the way you make the decision here is how frequently you are able to update your application. So some programs, specifically in big enterprises, they may have some apps and don't have a lot of dedicated developers, and revving their framework version every year sounds like pulling teeth, right? If you're in that situation, LTS is the answer for you, right? You want something that you can count on. It's going to be nice and stable. You're going to get 3 years worth of support. Everyone's happy, right? If you are in a situation where you're on a team that likes to and is able to update fairly frequently, feel free to grab any of these standard term supports. And I'm trying to remember what the old name was for this. this is the one that confused everybody. There is no reduction in quality standards, right? The same quality standards that Microsoft holds their LTS releases to is the same quality standards they hold their STS releases to. It's just that for them, there's a big overhead if you have to maintain every single release for 3 years. Like every version they're supporting adds overhead. And so what they've said that they're going to do is every even numbered release, so 6, 8, etc., is going to be the LTS 3-year support. And every odd numbered one, so 5 and now 7, is going to be an STS release, so standard term support. Meaning they're only going to actually have support for it for 18 months. And because they're releasing new versions every year, if you are able to update your framework version every 12 months, and that sounds like a good thing to you and not like a bad thing, then feel free to grab an STS version, right? It's all about how long Microsoft is going to support them for. There is no difference in the quality bar, right? The same set of testing that goes into an STS release goes into an LTS release. It's the exact same stuff. The only difference is how long they're going to end up supporting them for. So worth noting, as that could make the decision about whether you jump into Net 7 right away or not. Okay, so let's play around with some of these things because I've read through this list and I've looked at them a lot, but some of these I'm actually curious as to how they're implemented. So, and I'm going to do these kind of in a random order that I pick completely arbitrarily. Where was the raw string literals? I think this is what I'm looking for. Yeah. So I think the way I could sum up all of these features in C#11, smoothing over rough edges and just adding quality of life stuff. So raw string literals. So we've got a situation, and again, I'm gonna play with this. I haven't played with it, so this is all just figuring it out. All right. So let's go string foo gets bing, bing, bing. Huh? Yeah. See that nice tooling support? This is line 1. This is line 2. Thank you, Copilot. You want to try again? 4. This is indented. Boom. Semicolon. Okay. And then we're going to come down here and we are just going to write out foo. No thinking. Chip. Easy app. Boom. Okay. Not surprising. It outputs a string. The nice thing here, like some other language might call these here strings. I've seen that term thrown around. I'm familiar with it for like Terraform, or I guess HCL is the magical incantation there. But the important thing to note here is, one, the indentation level. So if I back this guy up to here and rerun it, because you'll note with the string indented to here, this was nice justification. If I back this guy up, you'll note now everything is indented. So your closing marker determines your left trim, I think is probably the cleanest way to say that. So you can, and I'm actually curious kind of what happens if I do this. Oh. Cool, straight up compile error. So if you indent too far, because that doesn't make sense, but it now allows, because especially if you're like inside of a method and there's already some nesting, typically what would happen before is when we would do raw string literals is we'd run into this fun problem where now you have to do this funky new line bits. No more funky new line bits. You can do this. And now you might ask the question, well, hang on, what if I want to have a string that has quotes in it, right? So one, this is convenient, right? And actually we'll quote this one. This is line 1. And then, you know, we'll do the sarcastic. This is line 2. But now what happens if I have 3 quotes in it, right? Well, the way you escape it is this just needs to be 3 or more quotes, right? 3 or more. And now that there's 4 quotes here, denoting this, 3 quotes is now perfectly legit, right? And you can just keep adding as much as your heart's content. The rules, as I understand it, the closing one has to be on its own line, and it will, and it's going to control that left trim bits. And this one, it doesn't matter, right? We can move it up, we can move it down. Either one is fine. We get a nice thing, and it escapes nicely. This is one of those things that's like, yeah, this is going to make writing big strings really nice, because occasionally I need that, right? Now, the one thing I did want to take a look at here, yeah, there's the left trim bits, 2 braces. I don't really want to read the full thingy here. That sounds like a lot of reading. I am interested in how this works here with the $sign. So let's play with that. So if I do this, right, and I'm gonna go int number gets, and 42 is obviously the correct answer. If you don't get this joke, Princess Bride movie, wonderful. This is indented, and we're gonna go here, and we're gonna go with number, right? And so they did double $sign. Ah, got it. So if you're building up like a large JSON string, right? Because before, with string interpolation, string bar gets, right? Before, we used to write something like this. Like if I wanted to do a JSON string, I would end up doing, well, I'd have to escape my curly braces by doing 2 of them, right? And then I'd have to go, key, and I'd have to escape the quotes and escape the quotes. Oh, but this is a literal, so that doesn't work. I guess I could go, well, ugh. Yeah, so this gets ugly because this, yeah. We're gonna just throw all that away. But now if I want to be able to do the equivalent, right, I could just go there, key, and then, number. But because I want this one to actually be interpolation, I do this. And I assume if I do a triple one, okay. For anybody who hasn't seen my calamities talk, this looks like a beautiful thing to build out. This is ripe. This feature is ripe for writing some code that is completely unreadable. Don't do that. But I see some ludicrous lines of code coming from this. I am going to totally abuse this. So, short version, if you're doing JSON or anything else that has curly braces, double things. And we probably don't need 4 quotes. You probably only need the 3. Because realistically, how many literal strings do you have that have triple quotes in a row? I'm going to go with probably not that many. In fact, I don't think I have any in any app I've ever written. Yeah, I'm going to go with that. So that's cool. We like that. Okay. Raw string literals. Cool. Those are cool. Those are nice. Those are happy. Let's see. Warning wave 7. I don't know what this is. Let's see. Any new keywords will be all lowercase ASCII characters. Oh, okay. So this is just a new warning. And in short, like some basic coding guidelines will take you a long way. Like there is a great talk, day 1 of .NET Conf. It was near the end of the day, where the Microsoft Teams team was walking through their experience on their migration from .NET Framework to .NET Core 3.1 to .NET 6. And it was basically just a long list of lessons learned and things that they ran into along the way. Kind of cool. Apparently, they cut their operating costs by $1 million just by revving the framework. All because of reduced like memory and CPU consumption and that kind of thing. That's pretty good. So, performance is a feature. You should update if that matters to you. Because the performance metrics of Net 7 over Net 6 there's some significant bits there. But short version, don't name your classes all lowercase, which is fine, right? For anybody looking for a basic coding guideline in C#, the standard way that we name classes is with Pascal casing. So, in theory, anybody who's following standard naming conventions won't run into this ever. So, okay, great. That's fine. Take me back. Oh, I control clicked it. Got it. Okay. Improved method group conversion. Let's see. Review. Previous versions of the standard prohibited the compiler from reusing the delegate object created from a method group conversion. The C#11 compiler caches the delegate object created from a method group conversion and reuses that single delegate object. Oh, that's kind of cool. That's kind of cool. Okay, so what does that actually mean, right? So let's imagine I've got a method, public void do stuff, because that's what we're going with. And I've got action of, I don't know, string. Sure, action sounds great. Boom. Right? And we'll just, oh, we should put this in a class. Public class things. See, we're gonna just test that lowercase bit right away. Boom. Format. Go. Nope. Things. You gonna warn me again? Yeah. Naming rule violation. Cool. So if you have warnings as errors in all lowercase classes, that could be a breaking change to you. Okay. Mark you as static. Sure. Fine. What are you squawking at me for? Oh, action of string. So it wants a string. 42. Done. Okay. So we'll do that. We'll do that. We'll do that. So, how about public static void print string value. All right, so we'll do this, and this will just do a console write line of value. So method group conversion is when you have, and I'll just make this static too, because why not? Sure, foo, you can stay there. If we do things do stuff, right, and I pass in things print, right, this is a method group. And if I'm understanding this correctly, this guy will now cache the delegate created from the method group conversion and reuse that single delegate object. Which makes me wonder, if I do this, what actually is going to happen. So I apologize. We're going to look at some IL. Because sometimes reading IL is nice. So let me clear this out. All the stuff. No, stop it. Stop it. Stop loading things. Let's see here. Boom, boom, boom. It outputted 42 twice. Great. Okay, open containing folder. Debug. For people unfamiliar with this program, it is dnspy. It is unfortunately my decompiler of choice. I say unfortunately because the project's been archived on GitHub, which makes me sad. Okay, so if we look here, what I am looking to see is down here. So this is where, so real quick lesson in, there we go. Sweet. Okay, quick lesson in IL for people who haven't looked at this before. There's a deep talk of doing stuff like this, and at one point I did a talk on IL, and I'm pretty sure I bored everyone to death because this is a level of complexity that most people don't even care to think about. But so short version, if anybody's taken an assembly class in like at university or similar, this will feel familiar. Everything works kind of like a stack, and as you execute through the method, there is always the opcode and then the optional value that gets passed to the opcode. And some of these, even without much knowledge, you can kind of start to reason through what these are. And oftentimes, if you click on these, you can just get the definition for them, right? So LDFTN pushes an unmanaged pointer type onto the stack. Right? So at each step of the way, it's all about looking at and knowing what's on the stack. So when you actually do a method call, the parameters that get passed are going to be the things on the stack, right? With the first one being the instance values, next one's first parameter, static is just a first parameter. So what I'm seeing here is this loads the function pointer onto the stack. So top item is the function pointer. It calls new, creating a new delegate type. And this guy here is going to ingest the top two things off the stack, right? And so you'll note the thing above it was load null. So we had function pointer, null as our top two items. This thing loaded both of those items off of the stack, created a new object on the stack. That's now the top item. This is called dupe. And I don't know why, or why that's necessary, but it does. And then this is the, this is probably why. This is the caching. So there's a generated field behind the scenes for the action delegate that it created. And then it called do stuff, passing the value that was top on the stack. So this is why it's duped. New object puts the action delegate on top of the stack. Dupe doubles it. So the top two items are now both referring to this guy. This one pops the top value off the stack, assigns it into a field. This one does an invocation, popping the next value off of the stack and passing it as the parameter into do stuff. Cool. And so then when it comes into here, it reuses that same method delegate from the same field, and we're off to the races. That's kind of cool. So short version, you get this nice, ugly looking generated class. And typically the compiler does this. So there are naming rules in C# about how you can name things, but there's different naming rules at the IL level. And so quite often what the compiler likes to do is anything it generates, it usually generates a name that's an invalid identifier in C#, just to avoid naming collisions, because then they don't have to worry about it. It's really hard to collide if you pick a name that the people writing the C# couldn't have picked themselves. So that's kind of cool. Okay, so that was a long, complicated way of saying, hey, look, it now caches this delegate. Is that useful? I don't know, probably. But you get a nice little performance bump for not changing a single line of your code. So cool. This invocation uses the cached delegate that this one stored in the field. That's kind of cool. Let's go back and see what else. Back to the top. Okay. Generic attributes, new lines and string interpolation. Okay. This one has annoyed me for a while. And so seeing this fixed makes me really, really happy. So text inside of the curly braces for string interpolation can now span multiple lines. Hallelujah. Hallelujah. Okay. So previously, right, if we did string bar, and then we did, number, about number is, we'll make it interesting, right? This is valid, right? But now this is valid. And normally we don't care about this, right? Normally these new lines didn't matter right up until you decided that you wanted to do fancy stuff, right? Like number greater than 42, right? Then put, is a big, otherwise put small, right? Like this used to be a major pain, and it's still kind of a pain because you have to do this garbage. I'll explain the parens in a moment, but we can now at least start making these things span over multiple lines to kind of start making the thing line up nicely and do this kind of jazz, which is cool. The parens inside of the string interpolation are all because typically, let me do a second one and I'll do it here. So number is, right? So in C# we have format specifiers. So for example, if we wanted to treat number as a currency, right? I believe it's C1. So this is the reason why you end up having to put these parens around anytime you do a ternary, because colon was already used as a delimiter for format specifiers. So you have to put the parens around it so that the string interpolation knows that this is something to be evaluated as code and not something that's supposed to be evaluated as a format specifier. So, but now it can span multiple lines. So, woo! Okay, quality of life got better. Everyone's happy. Great. Okay, list patterns I was going to come back to. Generic attributes. This one is just one that has been annoying for a while. Is anytime you had to pass a type to an attribute, you had to do type of, and now you can do generics, like real generics. So, yay! Like, this will be handy and clean up a lot of stuff. I'm somewhat tempted to, for people who watch the stream where we created a unit test generator with a source generator, this will make that a lot cleaner. No more type of. I'll say one less instance where you need type of. Type of will never completely die. There's always going to be places where it's necessary, but I much prefer generics where you can kind of thread the type right on through versus having to use a type of. Because the moment you do a type of, the code inside of this attribute now has to act on a system.type. Whereas the code inside of this can act on a T, which then which then allows more generics inside of the code on your generic attribute. And it's all, yeah, which I think that just makes things a little bit nicer. Just a little bit nicer. For anybody interested, if I show so for example, if we look at AutoMocker, so this is practical use case. So this guy here, if we look at the tests, is it here? No, it's here. Yeah. So before we had to specify, let me make that a little bigger, and you a little bit smaller. So before, when using this test generator, you would decorate your class with constructor tests, and you'd have to tell it the target type that you wanted to generate the test for. And so you have to do target type, type of, and yada, yada, yada. And there's some kind of cleaner syntax where you can just pass it straight on the constructor, which is great. But this is one of those cases where I'm tempted to go in and do a special C#11 version that allows you to do this as generics. Because I'd rather type constructor test, generic controller and call it a day. That would make me happy. So that's now on my backlog of project things that I want to go do. So unless somebody beats me to it, if somebody wants to go implement that, you do have to use pound-ifs because we have to keep supporting older C#lang versions, but it'd be a nice thing to add. So again, I count that as quality of life stuff. Ref fields and scoped ref. This is one of those use cases that the number of people who need it, if you need this, you already are excited about this. If you're questioning what it is, you don't need it. Okay, moving on. This one is interesting. So, native sized integers. This is one that is potentially one of those small performance bumps that you can start using sooner rather than later. So the idea is that, and this is driven by, oh boy, so I was hoping there was a short explanation. There is a better doc that I found on this at some point, and I don't know where it is, but it's not linked here. So native sized integers for nint and nuint, these ones will size based upon the bitness of the running process. So even though I'm on a 64-bit version of Windows, if my process runs underneath 32-bit emulation, so the x86 emulation, the size of my native int is going to be 32 bits. But there's some nice performance benefits for having things line up nicely on the CPU register size. So you can use nint and right, so let's go here. Nint. Ooh, let's go up here. Yeah, native sized integer, baby. So you can use this as you would mostly like a normal integer. But because you don't necessarily, unless you make extra checks, you really can't assume that this is bigger than a 32-bit. And even though 32-bit operating systems, it's like, well, most things are going to be running 64-bit. It's like, well, but ARM is now making a comeback. So, yeah. Oh, nice. So now you don't need directives. You can just publish and build for any architecture, and it'll natively select the correct int type. Correct. Or select the appropriate size for an int. The other thing is, this thing kind of behaves a lot like you would expect from the regular int class. Because you've got like min value, max value, right? So you can do some stuff to kind of like find your way into what is the appropriate size. But if you start using this, you do need to keep that idea in your head that, yes, this is a nice convenience, but you need to be careful that you don't like make assumptions that it's going to be, 32 bits wide or 64 bits wide. But again, another nice little quality of life, specifically for things that were previously going down to int pointer or similar for a lot of interop cases. This is probably going to be really nice. These are slightly different. So, and this is something worth calling out, right? So int, right, keyword is just an alias for int32. And nint isn't quite the same, right? It's not just a blind alias. Because it's switching that size at runtime, it's a little different than just a blind find and replace alias. Because if I type the keyword int, I do int32j, if we look at these two variables in dnspy, I get the exact same thing. This isn't quite the same, right? So, yeah. So, just be aware of it. Okay, what else? Pattern matching on span on a constant string. This is one that, again, I feel like if you know it, you'll be happy about it. Just because so many overloads have started using spans, this becomes a little bit more prevalent. So, for people unfamiliar, the span was introduced in C# 9, I think is when it first dropped. Don't quote me, going from memory. But the idea is if you're familiar with like database constructs where you have tables and then views into that table, if you picture your string as a set of data, a span is just a view into that. And oftentimes, so a span of char is just a view into a string. So rather than like chunking up your string into actual substrings, which requires string allocations, span lets you keep your original memory allocation of a string, but maybe look at this view of it, right? So, for example, if I go span of char, substring gets, and I don't know, Kevin, and then I do one ... I don't know, caret 2, right? Boom. Use as span. Okay, fine. And oh, can I just do the straight overload into here and get away with it this way? Oh, this is read-only span. Fine. Read-only span. Happy? Happy now? I just want to see your overload. Start length, right? So start at 1, give me a length of 3, right? So now I have a span of characters. So it's very similar in a lot of cases. If you've already using like substring, the method on string, oftentimes switching to a span will be a nice performance bump because substring is going to allocate you a new string with just, the characters you asked for. Whereas this gives you mostly the exact same behavior, right? I'm going to end up with a substring that starts on the first character and goes 3, right? So I'm going to get EVI in the middle of it, but I haven't allocated any extra memory. So this is how a lot of libraries, like the Community Toolkit MVVM library, there is some awesome stuff that they do in there to either get down to 0 allocations or real low allocation values. And in C#, there is a huge performance bump from reducing memory allocations. Because of the garbage collector, if you can cut down memory allocations, you will see a performance increase. So at one point in time, there was a video I was watching, and I'm trying to remember who it was. But the presenter at the time made the statement that you don't ever have performance problems. You have memory problems, and memory problems. You solve those and the problem goes away. So basically, we've now added pattern matching against a constant string, which I assume that means I can now do if substring is EVIN. Huzzah. Because that's a pattern match on a constant string. Great. Exciting. Extended name up. So this one is actually really interesting to me. So this is changing up the places where you can actually use the name of operator. So people unfamiliar with it, right? I'm just going to make a mess. This code's going to be a complete nightmare when we're done with it. So, right, string name gets name of foo, right? This is identical. How about? You can't pick on a variable that hasn't been declared yet. So we'll pick on number, right? So this is literally the equivalent of having it be equal to the constant value of number. The only advantage of name of is now if I do some sort of refactoring, right, and I change it, it now updates, which is convenient, right? We don't like magical strings in our code, and being able to use the refactoring is nice. But this extends where you're able to use name of, and this I wanted to test. So if you do it on an attribute declaration on the method, you can use the name of operator to specify the name of a method parameter in the attribute or the parameter declaration for nullable analysis. Okay, so, right? So if we come in here, can be null. Can be null. There we go. Right, so we do there. Why is it not finding so the using statement that I want is using system.code. Do I not get code analysis? Is that just bundled into the box now? Am I crazy? Me. Oh, allow null, maybe null. Okay, I'm getting the names of it wrong. So how about allow null? Find it. There we go. Diagnostics code analysis. That's what I was missing. Diagnostics. Okay, so but this is specifically for, what does this say? Attribute declaration on the method. So rather than putting the attribute on the parameter, I want to do it on a method with a return value. So public, how about string pry parse, how about string value, right? And we need to make you static. Okay, so, oh, and actually, pry parse should be a bool. Out int, I don't know, number. There we go. Great. Okay, So number gets 42, return true, right? Implementation optional. Not null when. And this is, oh, but this isn't quite, okay, so I need one of the parameters that actually takes in, I need one of the parameters that actually takes in the parameter name. Which one of these things takes in a parameter name? Disallow null. I know I've run into this case. I'm just struggling to find the one where I would need the name of. Ahaha. This will work. Let's grab this, because this is what I want to see the IntelliSense trigger on. Yeah, get rid of that. Boom. Okay, so public static. Hush now. Hush now. So return null. Boom. Not null if not null. So if the incoming URL is not null, this method is declared to not null. So if URL is null, return null. Otherwise, I don't know, return 42. So this is a stupid implementation. Get value. Sure. It's dumb. But the important thing here is this name of is now able to target parameter names. So it seems like, well, there it is in the IntelliSense. Okay. If I come in here and go string other, right? What I want to see here is OT. Cool. So effectively this name, if you have an attribute decorating a method, you can now use name of to target parameter names, which is something that was previously not possible. Cool. That's kind of slick. It's one of those use cases that it's always been annoying when you get into that situation where it's like, well, because I have no way to target name of on a parameter, I have to do this. And that always just is yucky. So, yay. That's kind of nice. Let's look at the UTF string literals. I don't know if this actually matters. Okay, so UTF string literals. So this is mildly convenient. So if you actually need a UTF string, now does this actually? Oh, so this is a little different than a lot of other things. So I guess it kind of makes sense. So for example, if you wanted a long, right? You would do 42L, right? So there's a suffix on the end of the value. Like I guess there is symmetry there. But if I wanted this one to be it, does it handle it if it's an interpolated string? Probably not. This should work. So if I do, and this is the other thing, is it doesn't return a string back to you. It returns back a read-only span of bytes, which unfortunately makes sense, right? Because strings in .NET are UTF-16, but occasionally you do need UTF-8, and so oftentimes what would happen is you would see people going through the encoding class when you needed this previously. So you do like system.text.encoding, right? And then you do something like UTF-8 get bytes, right? And then you'd feed it in, get bytes. So this looks like to be a shorthand of that. Okay, great. I mean, it's slightly different, right? Because this is a span. So whereas the other one's going to allocate the string into all of this, just like we were talking about a second ago with span being a view into that. I imagine that's probably all this is doing, is avoiding the allocation, which I approve of things avoiding allocations. Okay, auto default structs. This was one that, again, it's one of those, if you love it, you're probably already familiar with it. So structs were previously not always initializing all of their values. Structs in C# can often be a pain in the neck because people expect them to work like reference type classes, and they don't. And this was one example of how that would happen. And yeah, this is just a little bit nicer. Now things behave the way you expect. Huzzah. Great. Okay, so now we get to the ones that I'm really, really excited to play with. Let's do file scope types first. Yeah, because this is one I'm curious to play around with to see exactly how it works. Okay, so there, quite often, I will tell people when I see them write code to always specify their protection modifier on things. I always hate when I see class space name. And I usually tell people, I'm like, I'm fine if you leave the access modifiers off, but I get to quiz you on what they actually are. Because they aren't all consistent. That's the part that gets hard. Like the default value, if you write something and eliminate all of your modifiers, is different depending on whether you're talking about a class, a method. What's the other one that's weird? Class, method, property, field. Those don't all have the same default values. So this is where things get fun. Is this one sort of throws what used to be normal on its head, because for a long time in C#, the modifiers that you had were public, public, internal, public, protected, internal, protected, private, and then we added protected, private. I feel like I'm missing one more in there. One more combination of them. Again, complicated. But this one is file scoped. So hidden widget. So, and the place where I see this being really useful is once again inside of source generators. Because if I can declare something and all I'm trying to do is avoid conflicts with something that, like, because if I write a source generator and I generate a class, I have to make sure that whatever I'm generating doesn't conflict with something that, you know, whoever is using my source generator has already written. And that can be kind of a pain. And so sometimes you hide it off in a namespace or whatever, and that's fine. Kind of a pain. So yeah, let's play with this. So file scoping. I don't care to keep you around. So let's do this. So one, I'm going to change you from public to file, right? And I'm going to add me one more file. Add class stuff. Right, great. Still bothers me that you haven't updated the default template Visual Studio, but whatever, right? So if I go here, can I declare a public class things? It was things, right? Yeah, public class things. And that compiles, huh? Oh, that is so slick. So I've got a things here, and I've got a things here. Okay, I got to look at what it did. Reload all assemblies. How did that generate? Oh, that is dirty. So my things class got generated as program insert thingy that looks way bigger than a GUID here, double underscore things, and it put it all in here. Again, I'm assuming this is the compiler just going, we're going to make real sure we don't conflict with something. Interesting that they did that. Because here's my other one that's actually in a namespace, right? So I've got my things and I've got my stuff from my other file sitting over here. That's pretty cool. Okay, so now what happens if I do partials? Right, so if I do public partial class stuff, right, and I do other stuff, right, so we're going to go here, we're going to get rid of this. So that will definitely conflict. And if inside of here I go file class foo stuff, right? Public void foo, right? And I do public static void go. As the night drags on, my naming is going to get worse. Okay. I do love how it's... Thank you, Copilot? No, not helpful. Okay, so foo stuff go, right? So I can write this here. Okay, fine. I'll mark you as static. Right? Now, I'm guessing if I take this and I go over here, that same method doesn't work. Oh, that is so wacko. That is so weird that I can make something that is then restricted to just that. That is weird because that means I can take something, right? And let's do it as a nested one, right? If I go here, let's see, file local type must be defined in top level. Okay, so you can't nest them. But I guess it doesn't matter. It doesn't really matter that you can't nest them. Because you can scope them to the individual file. Yeah, it's okay. And so foo2, right? Stop complaining. So because you can scope them to a file, and because you can have any number of partials that you want, you really can lock it down to just you can make a type that's only accessible to a portion of a class. Wow. That's kind of cool. That is kind of cool. I'm going to have to, I don't know where I'm going to use this. I don't doubt this feels like one of those things where I've got a shiny new hammer and I'm going to find a nail to use this with. I don't know where that makes sense. Like there's been a handful of times where I've had to declare something internal and I'm like, I really don't want this internal. Like I really, the thing is those use cases that I can think of, I've really wanted it scoped to a namespace, not to a file. But I wonder if some of those cases could fall into this work and make it and have it go through. That's a possibility. That's a possibility. That still though, that's no worky. That is pretty slick though. Okay, so one, it works exactly as designed. It scopes the thing just to the file. So the file restricts a top level type. So it's only valid on types. So you aren't going to do this on like methods or something. Let me just make sure of that. I'm pretty sure that's if I'm reading that right. So I can't make you file. is not valid for this item. Yeah, so not surprised. I was gonna say it'd be really interesting if I could declare a method that was only accessible inside of here, because then I would have something better than private, right? If rather than making it private, I could just make it file limited, and that's now real lockdown. It's not only is it only available to this class, it's only available in this file in this class. Again, I kind of see the use case for this around source generation and wanting to generate things that don't conflict. So as long as you don't need it accessible outside, you can gen your types up in your source generator, and you don't have to worry about that problem. It's interesting too that you can do it on interfaces. Yeah, I'll have to think. I'll have to think about. Again, this is one of those. I feel like I have use cases for this. I just can't think of them. Still, cool feature. Cool feature. Okay, so generic math support. These are some of the more interesting ones. So this is something that I commented earlier about how some changes require the framework and the runtime that you need in order for this to actually work. So this is another one of those situations where that comes into play. So yeah. So the idea here is it is quite common, and I think the example they did is probably in here because I this morning. Oh, Tanner. The day 2, one of the opening talks is from Dustin and Mads, which they generally do a talk every time there's a new version of C#. And anytime you see Mads and Dustin doing a talk, watch it. It will be worth your time. It's awesome, right? I'll say that much. So once again, didn't disappoint. They go through a great example. Like this is, I guess their sample is fairly similar to this, right? And rather than write it out, it's probably easier to just talk through it. But the idea being that all of the built-in types, like system int32, now have this iNumber interface. And because interfaces can now support things like static and abstract on there, like that's the key thing. This generic math is a specific use case of some underlying features that got added, right? So static and virtual members in interfaces. So the interface 1 can be, the member on the interface can be static, right? That's kind of fun. And it can be virtual, which means it can have a default implementation, right? And then there's some other stuff around the checked and shift operators and unsigned right shift operators. These ones are less exciting. This one is the big deal, right? Yeah, explore static abstract interface members. This guy, this is where things start to get real weird, right? And the advantage here is operators. For those people unfamiliar, you can declare your own operators on your own types, right? If you want a plus operator on your cat object, you can add it. I don't know what you would add the cat with. Maybe cat and dog, or 2 cats. Get more cats, whatever. But when you declare an operator on a type, it's a static method. It's a static method with a very well-defined signature and a special name, right? So in this case, we're doing the plus operator, which I think is an addition. Might have to go and check. Should you use static for every variable? Generally not. So let me address that one really quick. So when you declare things as static, by definition, it means there's only one of them. And when you so static is very useful in a variety of situations where only one thing is necessary. So for example, like these static math methods that they have, these are what are called pure methods, meaning they don't have side effects. So I can invoke this as many times as I want. This is not mutating any data, it's just doing some calculations and giving back a result. Great. Statics are wonderful for pure type methods, or like link methods or similar. Those types of things work well. If you make everything, if you use static for every variable, you start to run into a situation where your code gets very tightly coupled, because everything that references that static variable is now tightly coupled to that variable, and it ends up being problematic. And it's not a bad thing to be coupled to a pure method because there's no side effects to it. But the moment you start like mutating state, now that's where that coupling starts to become real problematic. Is having public static for easy access. Yeah, so I would say I would separate out the concepts of public and static. So the public will give you easy access because you can now reference it from anywhere. The static oftentimes people will use for ease of access, because then they don't have to worry about which instance am I invoking on. It's static means there's only one. I'm just going to that one instance. Static can also be problematic when you start getting into things like threading, because if there's only a single instance of something, and you have multiple threads that want to access it, you now have to deal with synchronizing that access from multiple threads. Which, if you're just starting out, declare everything public static, go for it. What I've helped teach classes at the university level for C#, and oftentimes when we're first teaching students, that's how we'll have them declare things, is public static, because that's the easiest way to write code and get going. The moment you start building any sort of complex level application, though, you'll want to start separating out things that should be static from things that shouldn't be. And generally, things that should not be static are things that are holding on to data or doing manipulation of state. And what that means varies from application to application. And static methods generally should be anything that is a pure method. So doing work, but not necessarily mutating state. And that's, again, general guidelines, not hard and fast rules. There's exceptions to a lot of these. But oftentimes those are the guidelines I would go for. This ability here to do this on interfaces really kind of muddies the water, right? So a common interview question is to ask people, what's the difference between an interface and an abstract base class, right? That was a standard object-oriented interview question that comes up quite a lot. And it's oftentimes used to gauge like beginner, intermediate level candidates for how well do you know polymorphism? How well do you understand what an interface is used for? And I used to joke to people that interfaces, even before like C# 9, 10, and 11, where they added all this stuff to them, interfaces before that point were deceptively easy. Like they were easy to declare, easy to use, but I oftentimes saw people use them incorrectly. And so it was one of those, is like, yeah, now you can fall into the pit. They've added so much stuff to interfaces, it's real easy to fall into the pit of despair. So not shown here, you can actually put access modifiers on your interface members as well. So public, private. And in general, I see people doing that. And most of the time, they don't realize they're leveraging a newer language feature. And it's like, well, I declared my method that way on my class, therefore I declare it this way on my interface. It's like, probably not what you were intending. Don't do that. But because so much of the syntax now works, that difference between an abstract base class and an interface, especially in C#, that line's getting real blurry. Real blurry. So one, if you're unfamiliar with the difference between an interface and an abstract base class and when you should use each, I recommend looking it up. If you're still unsure, let me know. That might make a good candidate for one of those 10-minute videos. I'm making a mental list of ideas. So that's a great question. How often do you use the public class list of T generic types? Are generic types expensive? In C#, no. So this is often generic types in C# often will get compared against like Java's generic types, or like C. See if I can get this right. C++ is templates, and they're very different in all cases. And in C#, generally you actually want to use the generic types because they are less expensive than the non-generic types. So there are some collection types that don't require you to use generics, but the generic, oftentimes, if you say you have a list of ints, right? Okay, small side lesson. Here we go. Okay, so let's imagine we've got a list. So to answer your first question, all the time is how often we use generic types, and because they are typically the most efficient. So numbers, right? And we'll do. Let's see, new 1 2 3 4 5, right? So if you're unfamiliar with this newer syntax, this is newer C# syntax. This is called target types new expressions, which are absolute gold when using generics, because before we used to have to type this garbage, and that was annoying. And then the C# team gave us var, and that was better, but now we can do it this way, which is even nicer. It just, every version of the language, they keep adding features, and it's a little bit slow. Using link with generics. Yes. One specific comment about link in the last couple versions of .NET has gotten lots of love. Early versions of link, in like the NET Core 3.1-ish days, and I think NET Core like 2.0 days, there was comments from people where for loops were faster than link statements, because link statements tended to do lots of memory allocations. Now, the argument was usually, if I do a numbers where, right, where I do x mod 2 equals 0, right? I'm just going to grab toList, right? Var even numbers, right? So if I'm just going to pull out all the even numbers out of my list, there was an argument that every time you used a link method, because it had to allocate this delegate, because it had to instantiate the enumerator behind the scenes, it was a lot more expensive. Now, the counter argument was, yeah, but they're a heck of a lot easier to read, and they're a lot less error prone. So it's better to have less error prone code than more memory performant code. Well, the .NET team has actually significantly improved the performance of link methods over the last several versions. Because link is so common, oftentimes Microsoft looks at what's the most common thing being used and heavily optimizes that, because that's going to make the biggest difference in people's codes. So link has gotten, if you start looking at the source code, the link source code is it's gotten really complex, but it's all around that performance, because programmers want to write this. This is easy. The equivalent for loop of doing this is kind of a pain in the neck and ugly. And actually, real quick, so other thing, edu link. There is a wonderful, where is it? edu link, this one. So John Skeet put together a wonderful learning tutorial on link where he goes through and re-implements all of the link methods by hand. So if you are interested in learning link, it is worth noting his implementations are more akin to how link was when it was first introduced. These implementations are nowhere close to what link is today. But from a conceptual standpoint and understanding how link works and the behavior of all of these methods, this is awesome. Let's see, public volatile in storage. Ooh, so volatile is a keyword in C# that you rarely see used. So volatile is around memory fences, or memory barriers. I'm trying to remember the last time I actually needed the volatile keyword. I can't remember the last time I needed the volatile keyword. So the part about this that is the most interesting thing with this is the code that you write and the order that it executes aren't guaranteed. And usually people freak out when they hear that and go, wait, the code doesn't execute in the order I wrote? The answer is sometimes no. Now, obviously, if the code executed in a random order, there would be bugs everywhere. And since that isn't the case, we can conclude that yes, even though things may be done slightly out of order, what that really translates to is the IL instructions under the hood, like what we saw in here. These IL instructions may get reordered slightly for performance optimizations. The behavior remains the same. Now, because of that, there may come times, and they're pretty esoteric and they're really hard to hit. But you'll note this volatile keyword, all of the samples that you're going to run into are going to show multi-threading, because that's where it comes into play. Because things can execute out of order, and making sure that you are getting the correct value out of your field, that's when volatile is actually used. But in general, you typically don't use volatile that much at all. If you're doing something with a field and you think that you need volatile, generally a better solution is to look at the interlocked class. Because most of the time when people use volatile, it's because what they want is to basically synchronize access to a field. And interlocked, here, I'll just drop the link for this, is typically a better way to do that. So interlocked, the idea here is these methods are atomic, meaning that they can't be interrupted. So when you're thinking about CPU instructions and executing, and I'll point to the IL things don't necessarily correlate to CPU instructions, but conceptually that's fine. Anytime, what can happen is at any point your thread can get paused, right? Because your CPU only has so many threads inside of it, right? Like I think I've got a 16 core machine on my box, and so I've got a ton of programs running. What happens is the operating system has to schedule who gets to run on that CPU at a given time. Oh, thank you for the follow, Coldren. Because the operating system is scheduling which threads run at a given time, it means at some point in time, one thread has to be told, okay, you pause, hold on, it'll be your turn to come back in a second, right? And so my system, I don't know, probably has hundreds, maybe thousands of threads currently up and running for all of these programs, but only so many of them are running on the CPU at any given point in time. And the operating system is doing all this fancy switching. And that's where the multi-threading problem comes into play, because you can be frozen at any point in time and somebody else can go and muck with your stuff. And even once you start talking with multi-core computers, you don't even necessarily need to be frozen. It could just be another one of those guys is running at the same time and mucking with your stuff, right? So with a interlocked, specifically the compare exchange is an awesome method to become familiar with, because this does a comparison and then an exchange of values. And so you can do a lot of stuff with this, because normally comparing two objects and assigning to it ends up being multiple instructions, and this combines it down into a single instruction. And because it's a single instruction, there's no way for somebody to muck with your data in the middle, right? There's only one instruction there, and you're guaranteed static state. Unsafe static void fast copy. Not sure what the question is there. So that is potentially referring to the C# unsafe keyword. which that is just around enabling pointers in C#, because generally we don't have pointers. Okay, circling back to the abstract static bits on the interfaces. Effectively, what this does is you can now make up methods. And I think I like the, where was that blog link? Did I miss it? I had it open somewhere. Explore. This one. You can now start writing methods like this that act on things that are number-like, which is kind of cool, right? Like if you were told to sum up the numbers, but you weren't sure if the numbers were going to be ints, longs, doubles, whatever, right? All of those things you can plus equals on, which is great, but previously you ended up either writing overloads or doing various stuff to try to deal with all the different types. Now we have interfaces for all of the number types. And more importantly, those interfaces can declare operators. So types that allow addition now just work, which is pretty cool. And it's not just the addition operator. Like you can see that they added a whole slew of interfaces, right? Things that support addition, things that support bitwise operators, things that support comparisons or inequalities, right? Decrements, division, like they basically grouped all the like operators and made multiple interfaces for these things. So you can imagine if we look at, I'm pretty sure if I look at int, right? If I just F12 on int, right? You can see I've got all of these things in here that are now on it, and I'm looking for, I assume I signed number goes to, yeah. This guy now has all kinds of stuff. So if we were to look at the number of interfaces on any of the built-in numeric types, yeah, you're going to see tons of these. I number base, and whoo boy, here we go. And the interface tree just gets bigger and bigger and bigger. So very cool. I know I've bumped into needing this at points, but I think the addition of generic math, though really cool and helpful, is not nearly as cool to me as the underlying feature that enables it. Yeah, because I know I've run into situations where I want an interface to declare a static member, to say all types that have this interface need to have the following static on them, which previously didn't work and didn't make a lot of sense. And this is why interfaces are starting to become a little weird, right? Things are getting real blurry about when you use, an attached, not an attached property, an extension method or base class or whatnot. Okay, back to the top. Okay, and then let's do list patterns first. So this is one of those things that's just mildly nicer. Yeah. Where do they not have a good switch expression? They don't have a good switch expression. This is better, but yeah. Okay, so let's take our new numbers thing, right? So if I were to do switch on, well, actually, I need we'll just do an is, right? So if numbers is, and now I can start doing fun patterns inside of here, right? So if numbers is empty, if numbers has a single element of 1, right? Oh, ranges don't make sense here. I'm trying to remember this. Yeah, so inside, so before pattern matching worked, largely you'd start with the curly braces, right? And numbers is double curly brace. This was a property matching pattern that was a common way of checking for null, because this will match because there's no property specified here, this will match on all non-null objects, which is convenient, right? It's a nice null check. And then we got, is not null, and that's, in my opinion, even easier to read because that's nicer. Because before we didn't have the not null, we only had is null, but then we got not, which was cool. And now we can actually go inside of here and we can say, okay, what we would really like to do is, and I think this pattern here that they grab is just absolutely astounding, right? Like, this is bonkers. Is that... Oh, I don't think the dot dot is intended to be a range there. I think it's intended to be a pattern match. This is interesting. Subpatch into a slice pattern, which the following example shows. What? You claim this works. Let's just do this real quick. I want to make you an array. Boom. Int does not contain a definition of length. Yeah, I'm kind of surprised that this would work because inside of here, the list subpattern match allows you to compare against elements of the list. So rather than comparing against the list instance itself, like the is double curly brace, right? This is checking on the numbers instance directly. Sometimes what you want is actually pattern matches on the elements of the list, which is a little bit nicer. So for example, we want to compare, is my set of, actually this looks remarkably similar, right? Is my set of numbers equal to 1, 2, 3? Is it equal to 1, 2, 3, 4? Is it equal to 1, 2, 3, 4? You'll note this is not a subpattern. Stop it. But inside of here, we can start to say, okay, are the elements 0 or 1 or less than 2 greater than 3, right? Like you can start to, or I should say, is the first element 0 or 1? Is the next element less than 2? And is the third element greater than or equal to 3? Right, so you can start to build up these list patterny things. And then they do have a grab me the the dot dot, that's what it is, which is grab me the rest. So it's, I only want to match on the first little bit, and the dot dot is going to be everything else in the list because, a list can have an arbitrary number of things in it. Let's just go ahead and grab all of those. So again, useful, but feels like one of those use cases where all of these examples feel very contrived, and I will be, again, this is one of those, I feel like I've got use cases for this on real projects. Just can't think of one. But I've never had the power before. Okay, last thing in here. And then we'll take a brief gander over at the stuff in the framework. So required members. Why is it the things that have the shortest paragraphs are the things I'm the most excited about? Okay, so you can add the required modifier to properties and fields to enforce constructors and callers to initialize those values. And then you can slap an attribute on a constructor to inform the compiler that a constructor initializes all members. Interesting. Okay, so I'm curious as to how this is going to... So I kind of want to try this. Let's make us a type. Let's make us a type. So we're going to come over here. Public class. I keep using cat, so we're going to go with cat. Public required string name. Right, so I want that. Required must be settable. Okay, so we can either go with an init or a set. Let's just do set for now. Okay, and then if we come up here, cat c gets new, right, and that should give me an error. So must be set in an object initializer or an attribute constructor. So if I come here, name kitty, because that's the name of a cat, right? So that works. Interesting. So this is this is actually kind of nice, because before you could have an init member, but there was no way to guarantee that somebody actually set it. This is a little bit nicer, specifically for nullable reference types, right? Because before, without this guy, if I did this and I declared this non-nullable, what's up, Robert? Not WPF tonight, though. C#11, which is no less cool. Right? So if I declare this non-nullable and I try to set it to null, I appropriately get a warning. Right? Nullable reference types is enabled, which is this nullable attribute here. And on all new projects, you should definitely leave it enabled. It is wonderful. So I appropriately get a thing here. But you'll note down here, I'm also getting a warning, because there is no way for the compiler to validate that name is always set. Right? Because in the event that I just do this, c.name, dot length or whatever, this throws a no reference now. Because the default value of string, even though string is declared non-nullable, is still a reference type and still defaults to null. Right? And so there's various ways around this, right? Like you could default to empty string, but that's kind of annoying. It's like, well, I kind of want somebody to provide it. I can do it with a constructor, right? String name. But now that means everybody has to call it in a constructor. Right? And sometimes it's nicer to break things up across properties versus, right? Versus having to always specify, name here. Kitty. Right? Because if I want to have a default constructor now too, right? So I've got a default constructor in addition to my other one. My default constructor now gives me a warning saying, hang on, you've got a name property and you didn't initialize it to anything. World crazy. It's like, but I've got an init member, don't worry about it, right? Like cat C2 new, right? So name equals other kitty. Right? So even though I've created two cat instances, they both have their name non-null, I still get a warning here. Except for now, I can deal with this warning in a new way. Right? Because before we used to have to do something dumb where we like initialize named empty string. But now we can do this. Oh, and this is where the attribute comes into play. Cat name must be set in the object initializer or attribute constructor. Oh, interesting. On the second object creation, the object is created and then the property is set, correct? Yes. Yes, even though I'm using an object initializer, this is functionally equivalent to c2.name equals other kitty. This is just shorthand for setting a bunch of properties. And it's actually the only way. So even though it's functionally equivalent, you can't actually replace them, because there's a small but important difference here. Is this one is an init setter, which means this guy can assign to it, but this guy can't. Now, if this was a set, then you'd be golden in both cases. But init is only available inside of a constructor or an object initializer. Once you get past that initialization phase, the compiler doesn't know that you're going to assign to the property later on, so it can't check it. Whereas an object initializer gives it some scoping of, and scoping's the wrong word, because scope means something different. The object initializer has a well-known endpoint. We'll go with that. So the compiler knows once we've gotten past the initialization portion of this. It is interesting. So if you do this, you end up having to do, what was the name of that attribute? I've already forgotten it. Sets required members. Interesting. Okay. What happens if I do something else? Yeah, like that. Thank you, Copilot. You're amazing. Thank you for writing all my code for me. Cat C3 gets new, and I want to go with kitty and 42 because this is going to be an old cat. Interesting. So do I have to decorate this on all? Oh, this is kind of problematic because what happens if I do this and I do, right? Int age. Oh, this is actually kind of bad. Chain the constructors. Yeah, like that's the fix. Right? Like in reality, you should do exactly what you're suggesting, right? Of, you know, name and then, you know, reasonable default. But no, it doesn't catch it. That's what's weirding me out, right? No warning. Right? This one, even though age is marked as required, and I have no idea why Visual Studio has lost its mind on the color coding. Even though age is marked as required, this isn't caught. Because this is not setting age. That's mildly terrifying. Like, I really appreciate this feature, but like, and I get it. Like, inside of the compiler, it's really easy to put together simple examples like this, where it's like, yeah, the compiler should know about this. But there's plenty of examples where this gets real complicated inside the constructor, and it may not be obvious. And most of the compiler stuff where it's doing analysis, it has very low depth levels. Like, it doesn't recurse 4 or 5 layers into your code. Like the nullable reference types, I think it's only 1 or 2 levels deep. Like, it only is looking within the current method and the invocation and no deeper. It doesn't keep recursing and going, well, I know that if I run through all the paths that this thing is actually non-null, so I'm going to treat it that way. Like, no, it doesn't do that. It's much more naive and won't run that deep because there would be a huge performance penalty from doing that. This is really cool. It's like 90% of the way of what I want, because I want this to flag here too. Like, this thing doesn't have a list of members on it. Needless to say, thank you for the subscription. Man, that is so bad. So bad. Okay, so we're going to do one more thing. Public class kitten, right? And a kitten is going to derive from a cat because a kitten is a special cat. Right? So what happens if I do this? Cat C4 gets new kitten. Okay, that's good. That's good. Oh, thank you, Robert. I appreciate it. 8 months in a row. That's a lot. So it does appropriately flag that kitten isn't doing anything, right? But if I make this guy here invoke base and pass an empty string. Oh, okay. So this is mildly nicer. This constructor must add, okay, so if you have a derived constructor and you call into the base, you also have to set the attribute. Okay, so that fixes part of it. So you can't abuse it. You can't abuse it as easily with inheritance. But if you do overload your constructors, you got to be real diligent about when you apply the required, what do you call this? I can't use required attribute. What do we call it? Required modifier. So when you apply the required modifier, you have to be real diligent to go and check your constructors and with this attribute. Because if you change this attribute on a class, inheritance, now let's do interfaces. Yeah. Though this attribute is only, what is the spec on this? It's only valid on constructors, so you couldn't decorate an interface with this. Currently, constructors are not yet valid on interfaces. The moment they are, I'm going to question the point of an interface. We've already got static and abstract and virtual. We're getting there. We're getting there. Interfaces are this close to being full-fledged real object thingies. We're getting real close to it. That is interesting, though. Okay. So, I'll have to think. So, Intelitech, we put together coding guidelines, and we're in the process of updating them for C#11 stuff. And I am not sure, the best coding guideline I can come up with here is anytime you modify a required modifier or the set required members attribute, you need to review the other required members and constructors in your class to make sure that this is still true. Right? If you decorate this thing with required members, you need to make sure that you have actually assigned all required members, which is, it's better than not having it, because at least the amount of spots the programmer has to look at are all going to be constrained to this one class, right? Heaven forbid you have a class with 100 of these. That would be horrible to check. That would be miserable. I do wish that there was a slightly more checking on this to say, hey, if I put this on a constructor and I haven't actually handled it, please yell at me. I guess it couldn't actually validate that though, right? Because theoretically, this thing would be very valid if I did, age 2 here, right? So it couldn't flag the constructor with this attribute on it because it doesn't actually know. Yeah. How do you end up doing that then? It feels like the failure case is combining init level stuff and constructory stuff. If it comes in via the constructor, I would almost propose setting it up this way and then avoiding this attribute altogether, because now you appropriately flag. Right? Because if it's a read-only property, it's now only assignable in the constructor. It gets a little annoying, but yeah. I can see it now. This feature is going to be a major discussion point for coding guidelines of when and how to use it. Permission to yell at Kevin. Where is the Mountain Dew? For you, Robert. I know you can't see it. There, here. You're correct. My sanity was probably depleting. Mountain Dew re-engaged. Okay, so that is the C#11 language features. So just to be clear, if the developers and your build agents for your pipelines are all able to update to C#11, which means the latest SDK, do it. framework. See earlier in the video or recording of doing it. So this is now what is new in the .NET 7 framework. And I'll once again here, let me drop for people interested. Let me clean up the links so that it's actually pointed at non-language based links. Boom. So pro tip, you'll note the links that I'm sharing, all I'm doing is deleting this ENUS. So all the Microsoft links, if you drop that out of the link, it will tell the browser to infer the user's local language. And if it's one that's supported, it'll automatically flip into it. So for what it's worth. And language being like spoken language, like English, not this language that's programming language. Okay, let's see. So performance is a key thing here. Yes. And let me grab it here real quick. So there was a slide that got shared day one that I screenshotted because it was so cool. I'm just gonna drag this over here, right? So this is upgrading to .NET 6, right? So this isn't even .NET 7, but this is Microsoft saying, hey, we build on our own stuff. Let us show you. These are absolutely insane numbers, in my opinion, of just the amount of performance gains going up to .NET 6. So when in doubt, the latest versions gain a ton of performance, right? And so there are a ton of performance improvements in .NET 7. This is some of the areas that I've been actually keen to play around with, around the, what is it? Improved code gen for ARM64. Where is the, sorry, I'm looking for a specific bit that I read earlier. Oh, there. So, it's hiding under the native AOT. So, so one of the things that you can do with .NET 7 stuff is preemptively compile against different architectures. So rather than like the any CPU, if you know what you're doing, you can publish out and target the desired platform ahead of time. And theoretically it's easy. So you'll note like when this publish command is running, they're intentionally targeting one of the runtime identifiers, the RIDs. So 64-bit Windows, Linux ARM64. This also adds in, I guess it's not here. It also requires apps to be trimmed. So one of the things that was added, pretty sure it was added in .NET 6, I might have to double check, is app trimming. The idea being that it will inspect the code that you're invoking and trim off everything that you aren't. Because the .NET framework is a big, and most apps are not using all of it, like ever. Most apps are using some subset of it. And so quite often we can just trim off all of the bits that aren't needed. Now the problem is figuring out what bits aren't needed that can be trimmed off. And so finding libraries that are already built to be trim friendly, which usually means avoiding certain reflections and various bits. There is a entire document somewhere buried in here about how to make your libraries and apps trim friendly so that they can be reduced in size. So if AOT is interesting to you, definitely read up on that one because that is helpful. Let's see, performance improvements to Mono, which powers Blazor, WebAssembly, Android, iOS apps, yada, yada, yada. Great. So short version, .NET 7 goes muchos faster. We like speed. Okay, system text.json, more customization, great. So worth noting, so the two JSON systems in .NET now, there's Newtonsoft, which for a long time was the top downloaded NuGet package. And a large bit of that was because it was the JSON serializer for ASP.NET. Microsoft built their own JSON serialization library, not necessarily in competition. And I think the author of Newtonsoft actually helped them build this. So now there's a bit of a choice that you get to make. System.text.json tends to be more performant, but Newtonsoft.json has more features. So the question is, do you need features or do you need raw performance? And you kind of have to pick one or the other. Obviously, they're adding more features to it, but I don't think they'll ever hit feature parity because some features are just a performance hit. And for default ASP.NET Core, Microsoft is wanting it to be as fast as possible. So this one is actually pretty cool. The polymorphic serialization, because this was something theoretically very problematic. Is the native AOT related MAUI or totally different? It is not MAUI specific. So you can actually leverage it for a variety of different apps. So WPF, console applications, and I can just link straight into this article if you're interested. So this all comes down to setting up the appropriate settings on your CS proj, and then calling .NET publish. And the key thing here, though, is you do have to specifically call out which runtimes you want to target. So if you actually want to build a version of your app that's, x86 Windows and x64 Windows and Linux, you have to do the .NET publish on each of those, right? You have to actually build for each of those target architectures before it's going to work. But it means that each of those ones is going to be a smaller binary than if you were to just compile the NECPU runtime. So, worth checking out. This is another one that I wanted to go play with really quick. So, regular expressions. Now, because I have to share it. XKCD regex. If you haven't seen this one, you should. It's one of the early ones. It's pretty much gold. Right? So he slides in. Perl saves the day with regular expressions. Now, the corollary joke that always goes along with this is when you solve a problem with regular expressions, now you have two problems. So take that with a grain of salt as well. But what they did is they added this cool new regular expression source generator. And this is what I wanted to show. Yeah, non-backtracking, yada, yada, yada. That's all on how the state machine in regex works, which is very interesting and can make performance things go faster. I'm not interested in that. I am interested in the source generator for the compiled regular expressions. This thing. Yeah, this guy here. So, previously you had to write out your regexes, and it was quite common to take your regex classes and store them in statics. Because the building of the regex, specifically the regex's constructor, oftentimes, if it was done inside of a loop, could end up being a bit of a performance bottleneck. Now, a lot of that has been addressed in recent versions, but that's why you will often see this pattern here is building up of that regex, because the regex class has to parse this pattern to figure out what it's doing. And the parsing of the pattern, depending on how complex and big your pattern is, took time. And you didn't want to do that parsing of the pattern every single time. That was a bunch of work. So people would do it once, cache it in a static, right? Set compiled, ignore case, whatever. Now we have this. And this is kind of cool. So you declare a partial. So partial methods in C# kind of got they existed for a long time, and then when source generators came into play, they got a nice bump because now partial methods actually served a bit more of a purpose, because the source generators are often generating files alongside files. They generate, well, I'll call them virtual files. They aren't actual files on disk unless you set some properties, but they kind of generate files. But they're generating more partials to your existing classes. And so this partial method here, if you invoke it, does nothing, right? And previously you couldn't have a partial method that was non-void. And with source generators, they relaxed that requirement. They're like, well, tell you what, we'll allow non-void returns, but we'll throw an error if none of the generators actually populate an implementation. Because a partial method just says, okay, I'm going to declare the method here, and some other partial to this class will actually provide the implementation for this. And normally it's like, well, why would you do that? Why wouldn't you just write the implementation in place? Well, the only reason for that is things like source generators that might be building out that method for you on the fly, but you still want to have it declared. Now, previously, before source generators, when the rule was that this was void, what would happen was if nothing implemented that partial method, the compiler would just strip it out. Because it was void returning, there was never an assignment or anything. The compiler would just yank it and you wouldn't have that method call. Or if something populated the partial, then you would get it. And so it was kind of common with like preprocessor directives, like your pound-if debug, to have, you know, maybe I'll have this partial method that does some logging, but I'll only do it in debug and all that kind of jazz. And there's the conditional attribute and this kind of stuff. But this kind of thing is rather slick because now it can pre-compile your regex instance for you. It's not doing new regex. Rather, source generator is emitting C# code as a custom derived regex implementation. Oh, that is slick. That is slick. Okay, so regex, for people unfamiliar with this, so most regex engines build up a state machine, and actually this article here from Stephen Taub is actually probably, we're gonna pick on this thing very simple, right? Where does he show his regex pattern? Whatever. So as it's processing, effectively the regex engine is walking through that state machine, trying to decide, okay, is this string that I'm matching against something that fulfills my pattern? And there's all kinds of things to discuss here with like regex syntax. Is it greedy? Is it non-greedy? All of that. But at the end of the day, it's really just evaluating the string to say, does it fulfill this pattern? Or does some portion of this string fulfill this pattern? And recall my comment from before was the reason why we built up these static regex fields to hold this is because parsing of this pattern took some time. This is remarkable because rather than the regex engine parsing this pattern at runtime, it's parsing it at compile time. And that same sort of state machine that it would be building at runtime, it builds at compile time and emits it as straight C# code. That is frankly amazing. Oh, wait a minute. Does it seriously have... Okay, we're doing this. I gotta see this IntelliSense. This is just too slick. So show it to me. Okay. So Visual Studio, where'd you go? Come back. Boom. Okay, so let's imagine I want to do this regexy thing. Boom. Okay, generated regex. Great. You'll note when I pasted it, Visual Studio is getting really smart. Added the using statement for me. Thank you very much. Okay, so what do you require? Do I have to specify a language? That required. Where were they getting? Oh, that's where it gets it. Okay, this is even cooler. So on your partial method, you get some really slick IntelliSense if you hover on it. Matches a character in the set capital A, lowercase a. Then it matches on a character in the set B or B. That's cool. So it's showing you that it's effectively matching case insensitive ABC, case insensitive DEF, and those are ORed together. Ah, that is pretty much amazing. And if we look, hang on, stop it, don't help me. We go into our analyzers, what we should find here is underneath our regular expression generator, we expand it out, we can see that it generated this thingy here. So this is because it generated the XML docs for the method. That's how we're getting that prettiness, which is pretty slick. So what did it actually do under the hood? So hold on, regex. Oh, and look at that. They're using the file bit. Oh, that's... Well, I could have sworn the regex class used to be sealed. You'll note the derived class that they make for it is file scoped, which is now just straight up abusing that. And they can get away with this because there's going to be no conflicts because this is file based, which is, see, there's the good use case, right? File scoped classes, regex, pattern, builds a runner factory. So this is all just setting up the internals of the regex class. Wait, is this stuff protected internal? Interesting. Okay, I have to go and look. I don't think that this... I'm convinced there must have been a change to this class. Interesting. Let's look at reference source. Protected internal. So it's been this way for a while. Interesting. So reference source, you'll note, is targeted back on .NET Framework 4.8. So occasionally I will switch between these two just to get a little look at it. That is... I did not realize this was possible. Cool. Utilities, default timeout, app context, get data. Oh, that is just slick. They've thought of everything. They have thought of everything. So there is an equivalent on app context. There's a set data method as well that you could obviously use to set this. So if you want to set a regex default match timeout, app context, set data. That is absolutely slick. And then you can see this is the state machine. You can literally see the implementation that it's going through here. And once again, it's acting on those spans so that it avoids allocations. That is slick. That is very, very slick. And you see it's just slicing these things up. So normally you can conceptually think of slice almost like substring, but it's important to note that it's kind of like a view over a table in a database. It's not actually allocated, it's just shifting that window that it's looking into. Okay, that is cool. All regex should be this way now. That is really slick. Okay. And then there is probably... Okay, so a couple interesting things. Microseconds and nanoseconds are added. I'm curious... Yeah, microsecond and nanosecond. I may need to double check. A while back, like in the order of years. Yeah, I agree, Robert. It is nice to see that state machine. A while back, I remember looking at the performance counters in Windows. And if my memory is correct, they only had microsecond level accuracy. But I wonder if other performance counters might actually get down to nanoseconds. It's really hard to get down to nanosecond level accuracy at such a high level language. Like, the only time I've ever gotten into nanosecond level accuracy was writing assembly code on a real-time chip. Like, little like getting down that tight, nanosecond is not really that accurate. It's pretty tiny. But I don't know if the counters have that level, or like, I don't doubt that these are useful for people who are doing them to like date time. Okay, I want to add some milliseconds or that kind of thing. Right? Like, those are very good use cases. I just don't know if when reading it out, if that actually helps that much. Which is cool. Reading it. Ooh. This interests me a great deal. Because I've had to go into third-party libraries for tar archives. That's cool. The rate limiter is a slick little guy that was brought in. Its primary purpose was for ASP.NET, but anytime you need rate limiting, it is not that bad. Segments of 100 nanoseconds is approximately the best resolution you get. See, and that doesn't surprise me that much. Actually, 100 nanoseconds, that's still pretty small. Okay. APIs to read all of the data from a stream. Yeah, this one scares me. I guess this is a little better than the alternatives. So the idea being that streams, when you would read them, they could always return less data than you asked for. And depending on what the source of the stream was, that could be desirable or not. You do need to be a little careful with all these stream things when you're reading stuff in. There was a software program we were working on at one point, and one of the developers had called file read all bytes. That's really problematic when end users provide the files and then they feed you some massive 4 gig file. That bad. Don't do that. So don't read all the bytes in a file. You probably don't need that many bytes loaded in anyway. Like, it's really not likely that you need that much. +1 for date only. Yes. Yeah. So these ones are like, this has always felt something really awkward where you would end up using a date time object when you only needed half of it. Like, that was always really annoying. I do find, so this type here actually made me laugh when I first saw the name of it. Where's half? There's half converter, but there's the, yeah, then you're stuck formatting it every single time. Exactly. One of you in here has a, show me a link. No, I just want to, where's the half type? There is a, so there's a new floating point type called half, which, there, take me there. Yeah, it's a half precision floating point number, right? So if you need, because float is 32 bits, double is 64. So naturally we need a 16. The thing is, like, I suspect I probably only ever use this for interop scenarios, because the number of times I pick float over double are really small to begin with. And maybe there's better use cases, but we now have half, so that's cool. Metric support for memory cache, great. I suspect this was largely around the support for adding, what is it called, open metrics or open telemetry. The only two times I ever use floats now is for games and accuracy for arrays, etc. Yeah, I can see it being helpful for math related stuff. I tend to bump into the floats a lot doing like image processing, because depending on which imaging library you work with, anything that does kind of higher level math oftentimes will abuse floats for mathematics. And I don't doubt there's some performance to be gained there over double when the double's precision isn't needed. It's likely just slowing things down. But for most people, unless you have performance benchmarks that show that going from double to float is useful, don't make that switch. It's not worth it. Until you write a benchmark showing the gains from doing it, don't do it. It's not worth it. Always measure before making performance changes. Measure, 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 measure. Get Unix file permissions, great. This is just bringing Unix or system IO on Unix up to par on Windows, which is great. Attribute to index what kind of syntax is expected in a string. Oh, this is interesting. Composite format, date only format. Oh, this is kind of cool. I kind of like that. I'm a little weirded out that Twitch just sent me a there's normally like a stream summary email that comes through at the end of your stream. Yeah, Twitch just sent it to me. And I had to pause for a moment, make sure I was still streaming. Okay. I'm guessing I just rolled over past the midnight mark and it freaked out. This is kind of cool. Be curious to track down exactly which bits of code are looking at this, because attributes by themselves don't do anything, right? They're just metadata attached to your code. But things can use attributes to add behavior, like source generators. I'd kind of be curious which things are targeting this. Obviously, the regex one is probably leveraging it. But I'd be curious exactly what other things are leveraging it. Let's see. APIs to interact with JavaScript when running in the browser or WebAssembly architectures. This one doesn't surprise me. There's a huge push for the Blazor interop stuff. Aspect-oriented static weaving, yes. So this one, something with that doesn't surprise me at all. Let's see. Yeah, so open telemetry, better integration, not shocked. Like I've really appreciated all of these changes that have gone in to try to bring the common cases in .NET up to par and easy, right? Like plugging in telemetry is one line. And I can't remember, it might be in the new project template. So it might be 0 lines, which is stupid level easy. Let's see. .NET new CLI command creates new project configurations. They added tab completion. So I have talked with the PM that runs this. I am willing to make a strong bet that this is system command line. Yeah, this is the same docs for system command line. Yeah. So If you haven't gone through and turned on tab completion, you should do so. Because it works for, so tab completion works by registering a hook in your terminal shell, so that when you hit the tab key, your terminal actually makes invocation out to another exe to say, hey, provide me the completions. Right? By default, most people are familiar with the tab completing like folders and file names and that kind of thing, but it doesn't have to. It can do other stuff, which oftentimes when you're using a CLI tool, if I've already typed .NET install and I hit tab, boy, it'd be really nice to have useful stuff there. Yeah, so in this case, they added it to .NET New, because .NET New is the one where you can add in different or create new files or projects with the templates. So I'm guessing it just iterates through the various installed templates you have, which is cool. Template constraints let you define the context in which your templates are allowed. Oh, this sounds gold. Multiple forms of authentication. You can constrain your template to an operating system, a template engine host, and installed workload. This is perfect because I have been mentioning wanting to build some default WPF templates for a file new project, because I do it a bunch for my samples, and it would be really nice to have one that followed the standard pattern that I do. This is cool. This is cool. This is very much a niche use case for people making templates, but I am one of those people, so I care a great deal. Publish to a container. Yes. This is awesome too. I should have called this one out. So you can do. So this one actually came out back in August. And Chet has a wonderful article here. But so for people who are doing containerized stuff, right? The standard flow that you used to do is .NET build, compiles the thing, .NET publish, gives you your output artifacts, and then Docker build, right? To package all of those things up in a container, unless you were already in the container doing the .NET commands for the build and publish, whatever, right? Either way, you're running Docker commands. You no longer need Docker to make a container. This is awesome, right? I'll say that again. You no longer need Docker to build a container, because Docker did a wonderful thing, right? They went through all of the effort to make it a nice standard that other people could implement. It's just that most people didn't bother, because why? We have Docker. It's great. The problem is you have to have Docker installed, and that's yet one more thing inside of the .NET ecosystem that you had to get that wasn't necessarily, it didn't feel in the box, right? It worked great, but it wasn't necessarily in the box. Now with .NET Publish, you can get your image built for you. And more importantly, you can build the image and send it straight out to your container registry, right? Where's their sample? Customization, base image. Yeah, completely agreed. So container base image, and you get, so this is the other thing that I really like, is I like customizing like my publish and whatnot inside of my CS proj. Being able to do this now with my image stuff too, it means I get to put everything in my happy place, right? Inside of my CS proj, or if I get really fancy, my directory build.props file. Mwah! That way I can just drop that sucker in and be happy. Oh, love it. Yeah, CI pipelines. See, this is nice, but this isn't quite. This article is slightly older than what they demoed. So this was demoed day one of .NET Conf. And if you set up all of the properties in your CS proj, if assuming I followed their demo correctly, you could do .NET publish. It would build the image and send it straight up to the ACR. Now, that assumes that you've already authenticated against the ACR, right? You've either had to do like the AZ login or something to do that authentication ahead of time. Yeah, you can now manage common dependencies in your package. So here's the exciting part, right? This directory package.props file, this has been around for a very, very long time. Like, this has been a feature that's been requested from the NuGet team forever. And in fact, let me just show you. Here's how long we've been using it here. So directory packages.props, right? What's the history on this file? Where'd my history button go? Download, delete, history. There you are. When did we first touch this? So I've had this in here since November of 2020, and I'm pretty confident it existed since prior to that. But this was coming over when we converted away from Packet. So this has existed for a while, but it's been under like preview flags and whatnot. So it's finally in the box. Yeah. So effectively, the big idea here is you can have one file that declares all of your NuGet packages and the versions that they're at, and then all of your projects inside of that same folder. Rather than referencing the version of the NuGet package, they just say the name that they want, right? So I just say I want newtonsoft.json. But for it to know the version, it goes up to the central management for it to find the appropriate version to get, which is great. And this thing works basically the same way as the other directory star.props files. So if you want to do, like, it's going to walk up until it finds the first one. And if you want to keep doing recursive stuff, you got to add an extra line in there. But you can also, the pinning and all kinds of other stuff. So this is actually rather nice. And one of the things that's been lagging behind is nice editor support. And it's not clear to me if Visual Studio has been updated for this. I should double check and see, because I know that they wanted to improve the tooling around this. And before, like, yes, you could turn it on, but you had to edit the file yourself, and you got minimal help, which was kind of sucky. But if they've updated the tooling to go with this, this would be even cooler. P-invoke source generation. Oh. Have they relaxed the rules for extern? That would make me excited. This could make me mildly excited. So I've got a very specialized use case where I care about this, where I want to declare extern methods, but tell the compiler, don't worry about it. I got this. Like, I want an extern method, and I don't want to decorate it with anything, which at least prior has thrown warnings, and it seems like it probably still would, because they've just added a new attribute. Ah, so this is all around AOT enablement. Okay, fine, sure. Yeah, C#11, .NET MAUI, great. .NET MAUI is here, ASP.NET Core 7, EF Core 7, Windows Forms, got some nice updates. You'll note WPF is missing from this list. There wasn't any major updates to WPF. You can rev yourself up to Net 7 and gain all the performance stuff from under the hood, but there wasn't anything specific for WPF that I'm aware of. Yeah, and the upgrade assistant. So if you are on an older project, it is worth looking at the .NET upgrade assistant just to see how hard it's going to be to upgrade yourself off of it. The biggest hurdles are if you're on an old CS proj file. So if you double click on your CS proj file and it collapses rather than opens a file, you're on the old one. Right? That's usually the hardest upgrade. And there's two paths forward. The upgrade assistant generally can do a pretty good job. The other thing is you delete your old CS proj file, you make a brand new one, and you just import all your source code. Or at least put it in the same folder. And as long as your old one didn't have a ton of customization, you're probably fine. Yeah, that's what I did. Delete the old CS project, make a new one. For most projects, that's the path of least resistance. Because this SDK attribute brings in all of the magic for like, okay, find all the subdirectories and all the C# files in it and include those, and don't include the bin and obj direct. Like all of those default patterns are all just bundled underneath this SDK attribute now, which is great. That's you get all of the behavior you expect out of the gate. And as long as your old CS proj didn't do anything fancy, you're fine. And if you're under source control, just do it. Try it. Because you can always revert. If you're not under source control, make a backup copy. Don't do anything too crazy. So that is everything in C#11 and Net 7, at least according to these docs. There's always like the little straggler niche stuff that's off in the corner that wasn't important enough to warrant write up in these articles, but this is all of the cool big stuff. I will say some of this stuff makes me rather excited, and I think I said at the beginning, there's nothing in here that is like ooh, but there's a lot of quality of life stuff in here. This file scope types, yeah. I feel like this is going to be the one that I start to abuse and get yelled at for abusing in bad ways. Because I'm sure there's ways I'm going to abuse it. Like that's going to be kind of fun. That's going to be kind of fun. Because this is it's an access modifier that's not a real access modifier. So just to clarify what I mean by that. So access modifiers generally exist in your IL, but this thing isn't changing the access modifiers in the IL. Like there's no file level access when you get down to the IL level. There are no files. So the compiler's taking that, interpreting it ahead of time and going, okay, when you put the file access modifier on there, what I'm going to do is I'm just going to munge the name and appropriately forward all references to it and make sure that they're all in the same file. Because the compiler is the only thing that knows about files. Once you get compiled into the IL, there are no files. Like your symbol file, your PDB, has a reference to files, but there's no real concept of file beyond that point. And definitely not in the IL. So, cool. I think with that, I'm going to wrap up for the night. Thank you everyone for coming and hanging out. Hopefully people found that interesting. Like I said, if you haven't checked out the .NET Conf YouTube stuff, let me grab that link again. So, and no problem. Like I said, hopefully people found that interesting. I found it interesting because I love digging through some of the in-depth stuff. From the .NET Conf site, the key thing to do is their YouTube one. And then if you go to .NET, and then underneath the .NET Conf 2022 playlist, this is where you'll start to find a bunch of stuff related to individual sessions, or you can get the big long videos from like day 1, day 2 type thing. And the conference ain't over yet. You've got day 3 coming tomorrow. So we'll see what kind of coolness comes that way. So everyone, happy coding. See y'all next time.